Good morning, good afternoon, good evening. We are back and better than ever. Still extremely excited about the calculus. I know you like the calculus. We are talking about derivatives of logarithmic functions, and we cannot forget all the small things. No, we cannot. So we are going to do a little bit of an exploration to start here, to start a discussion on the derivatives of logarithmic functions. So I have graphed for you the logarithmic function, natural log of x. F of x equals natural log of x. It's big blue. I know you knew that. There it is right there. I have constructed a tangent line, t, in red there. And the tangent line is tangent at the point A, giving us the slope of the tangent, which I know you know is the slope of the tangent to the curve at point A, which means the slope, the gradient of the curve at this particular point is 0.536, which we can find with the derivative. Okay. I also have right here the coordinates of point A. And what I want you to look at real quick is the relationship of the slope of the tangent to the coordinate, the x-coordinate of the natural log of x. And you can see how it's changing when I pick and drag it. But this you can't see, just might not be able to see unless I was really good at being very specific about where to put point A. So I am going to pick some nice values of A. We'll start with 1. So when x is 1 in the natural log of x, what's the slope? Oh, the slope is 1. The slope of the tangent of the curve is 1. What about when x is 2? Oh, it's 0.5. And when x is 3? Oh, the slope of the tangent is 0.333. And I will give you a little bit of foresight on this. It's actually 0.333333333 forever, infinitely 0.33333 or 1/3. So how about 4? 0.25. How about 5? Hopefully you're seeing something here. You're getting, okay, the final one will do. The value, when the value of x for the natural log of x is 10, the slope is 0.1 or 1/10. And this is a visual, very soft proof of the fact that the derivative of the natural log of x is 1 over x, 1 over the x-coordinate. Let's review. When x is 10, 1 over 10 is 0.1, the slope of the tangent to the curve. When x is 5, 1 over 5 is 0.2, the slope of the tangent to the curve. When x is 4, 1 over 4 is 0.25. When x is 3, 1 over 3 is 0.33333, and so on. 2, 1 over 2 is 0.5. 1 over 1 is 1. Okay? So the proof, the actual proof that the derivative of the natural log of x is indeed 1 over x is a bit lengthy and beyond the, well, it's beyond the scope of this course. And this is from your formula sheet, so the derivative of the natural log of x is on your formula sheet. So let's have some fun. Find the gradient function of the natural log of kx, where k is a constant. Okay, so let's rock and roll. So for A, looks like we have the chain rule because we have a function, the natural log function, and then we have kx is another function. So we have a function within a function. And remember, that is the derivative of the outside multiplied by the derivative of the inside. Okay? So the inside function is kx to the first power. So the derivative of kx is k, yes, times the natural log, times the derivative of the natural log of x. Oh, what did I do? Derivative of outside times the derivative of the inside. I'm so sorry, I messed up. Okay, the outside function is the natural log function. So it's the derivative of the natural log of kx is 1 over kx. There we go. Okay, multiplied by the derivative of the inside. So sorry. And the derivative of kx is equal to k, which equals k over kx, which is equal to, bam, bam, 1 over x. Bazinga! There we go. So y prime is equal to 1 over x. Very good. So that means anytime you have a constant there, the natural log of the constant times x, the derivative is going to be 1 over x by the chain rule. Okay. So here, outside function is natural log of 1 minus 3x. So the derivative of the outside, we got chain rule again, is going to be 1 over whatever we're taking the natural log of. So that's going to be 1 over 1 minus 3x, derivative of the outside, multiplied by the derivative of the inside here. This is the inside function, okay? And the derivative of 1 minus 3x is just negative 3. So this will be equal to negative 3 over 1 minus 3x, done. And finally, C, we got a product rule. So let's see, that's going to be v du plus u dv, and u is x cubed, and v is 1 over x. So y prime is equal to v, natural log of x, times du times 3x squared, plus u, x cubed, dv times 1 over x. And we clean that up, and our final answer is going to be 3x squared, natural log of x, plus x squared. X cubed times 1 over x is x squared. And that is it for that. Okay. Now, sometimes we can use our laws of logarithms. This is from your formula sheet. These rules of logs to help us make taking the derivatives easier. And then, of course, the derivative of natural log is 1 over x. So let's see what we have got here. So A, I'm going to rewrite this as y equals the natural log of x plus the natural log of e to the negative x. Yes? And using my laws of logarithms, I'm going to say, and what did I just use? I used this one, the product. So then this would be, oh, wait a second, this is base e, yes? So the natural log of e to the negative x is simply equal to negative x. So then we have natural log of x, that's equal to negative x, so minus x. There we go. So the derivative is equal to 1 over x minus 1. And leave it. We're done. The derivative of natural log of x is 1 over x. Derivative of negative x is negative 1. Booyah! Okay. So this, I'm going to use the quotient log rule there. When I take the log of a over b, I can rewrite it as a subtraction problem. So I'm going to rewrite b as the natural log of x squared minus the natural log of x plus 2 times x minus 3. And then I'll use this rule again and rewrite the second part as y equals the natural log of x squared minus the natural log of x plus 2 plus the natural log of x minus 3. And that makes life much easier. We just have a couple of chain rule functions, or not chain rule functions. We got to use the chain rule 3 times. So y prime equals derivative of outside is going to be 1 over x squared times the derivative of the inside. The derivative of x squared is 2x minus derivative of the outside is 1 over x plus 2. That's the derivative of the natural log of x plus 2. The outside function is natural log, multiplied by the derivative of the inside here, which is just, let's see, 1, plus derivative of the outside, 1 over x minus 3, multiplied by the derivative of the inside. Derivative of x minus 3 is 1. And we clean that up. Now, I don't expect you to write the times 1. I just did it because I knew I was going to have to clean up here. This is going to be, what, 2 over x minus 1 over x plus 2 plus 1 over x minus 3. And the good news is there is absolutely no reason to make this one term, because we find the derivative to find the slope of the tangent to the curve at a particular value of x, and it's much easier to substitute for x a number for x and simplify to find that slope than to make this one a rational expression with one term. So that is it. Hope you enjoyed it. We will see you next time. I am out!